Good morning, students. Today's new topic in chemistry is isotopes. So this is important topic. Concentrate yourself. We are going to start. Isotopes are different atoms of an element with the same proton number but different nucleon number. So these are actually the different atoms of an element having same proton number but nucleon numbers are different. So this is the definition of the isotopes. Isotopes have the same number of the protons but different number of the neutrons. Isotopes of the same element have similar chemical properties but different physical properties. It is the number of the electrons which decides the chemical behavior. Same number of electrons means same chemical properties. The number of the neutrons in the nucleus does not affect the chemical behavior. Examples of some isotopes. So, bromine is an element that is having two isotopes, that is bromine 79 and bromine 81. And their relative abundance in the bromine is 50% each. Bromine 79 and bromine 81 both are having same proton number, that is 35, because isotopes are having same proton number but different neutron number. So look now, neutron number is also called mass number. So bromine 79 is having 79 mass number and bromine 81 is having 81 mass number. And number of the neutrons in bromine 79 is 44 and in bromine 81 is 46. Carbon is having three isotopes, that is carbon 12, carbon 13 and carbon 14. Relative abundance in the carbon is carbon 12 is 98.9%, carbon 13 is 1.1% and carbon 14 is less than 0.01%. Proton number is same, that is 6 of all three isotopes. Mass number, carbon 12 is having 12, carbon 13 is 13 and carbon 14 is 14 mass number. Number of the neutrons, carbon 12 is having 6, carbon 13 is having 7 and carbon 14 is having 8. Chlorine is having two isotopes, that is chlorine 35 and chlorine 37. Relative abundance of chlorine 35 is 75%, chlorine 37 is 25%. Proton number is same, that is 17 for both of the isotopes of the chlorine. Mass number is 35 for chlorine 35 and 37 for chlorine 37. Number of the neutrons in chlorine 35 is 18 and in chlorine 37 is 20. Copper is having two isotopes, that is copper 63 and copper 65. Relative abundance of copper 63 is 69%, copper 65 is 31%. Proton number is same, that is 29 for both of the isotopes. Mass number 63 for copper 63 and 65 for copper 65. Number of neutrons is 34 in copper 63 and 36 in copper 65. So the tip for you regarding paper, you have to remember 2 or 3 examples of the isotopes. For example, you can remember bromine's isotopes and their details, chlorine's isotopes and their details, and copper. So you have to remember 2-3 examples of isotopes, because in paper students are required to write down any 2 or 3 examples of the isotopes. Some isotopes are given special names. For example, these are the isotopes of the hydrogen. There are three isotopes. First one is hydrogen 1. The special name given is protium. Second isotope of hydrogen is hydrogen 2. Special name is deuterium. Third isotope of hydrogen is hydrogen 3. Special name is tritium. So these are very special isotopes given special names. Here is a question. Complete the table below. Hydrogen 1, hydrogen 2 and hydrogen 3. So requirement is proton, neutron. So in hydrogen 1, hydrogen 2 and hydrogen 3, proton is same because proton isotopes are having the same proton number but different nucleon number. So proton will be same, neutrons will be different. Hydrogen 1 is having 0 neutron. Hydrogen 2 is having 1 neutron. And hydrogen 3 is having 3 neutron. So these are very important things which you have to remember. Another question is, the particles present in 4 atoms are given in the following table. And here is a table. P, Q, R and S. There are 4 atoms and there are number of neutrons, protons and electrons are given. But the number of electrons of S are missing. Some requirements are there. First part is, how many electrons are there in one atom of S? So because their proton number is same, that is 12. So sorry, this is actually electrically neutral atom. So if proton numbers are 12, there will be same number of the electrons. So 12 will be electrons there. Second requirement is, what is the nucleon number of S? Here is S, and nucleon number is equal to protons plus neutrons. So 12 plus 12 will be equal to 24 is the nucleon number of S. Next requirement is, identify atom S and give its correct symbol. Because we are given the proton number, that is 12, and nucleon number, that is 24. So from the periodic table we can see this atom S is actually magnesium, proton number 12. The last requirement is, which atoms are isotopes? So P and R, because they have the same proton number but different nucleon number, and you can see from here P and R having same proton number but different nucleon numbers, because these will have, P will have nucleon number 10 and R will have nucleon number of 22, but proton number is same. So isotopes are having same proton number but different nucleon number. So P and R are the isotopes of the atom. And other question is here, use the following data on the element chlorine. 2. First part, find the missing fractional abundance X and mass number Y. So here is X and here is Y. That is the requirement. From here you can see percentage abundance is given 24.23, and in the bottom you can see this point moved to the 2 places to the left. So 0.2423. Same wise here, point is here, move point to 2 places left. So X will be equal to 0.7577. So this is the value of the X. And Y's requirement is, so 35 is actually nucleon number, that is here. And this 37 is the nucleon number of this, so y is equal to 37. This was the first part. Second requirement is calculate the relative atomic mass of chlorine. So, the method to find the relative atomic mass of the chlorine when relative abundance is given. The relative atomic mass of the chlorine, AR of chlorine, is weighted average mass of its isotopes, that is 34.97 multiplied by relative abundance, that is 75.77, plus likewise 36.97 multiplied by 24.23. Close it into the bracket, whole divided by 100. Solve it on the calculator. 35.46 will be the answer. Okay, here is another method. If you don't want to multiply the relative atomic mass with percentage abundance, multiply relative atomic mass with fractional abundance. So 34.97 multiplied by 0.7577 plus 36.97 multiplied by 0.2423. So solve it on the calculator, you will get the answer. The only difference is this full value will be divided by 100, but in this method, not divided by 100 will not be there. This is the only difference. Another question is here, and this is copper has two isotopes, copper 63 and copper 65. Copper 63 has relative isotopic mass of 62.9 and copper 65 is having 64.9. The relative atomic mass of the naturally occurring copper is 63.55. Calculate the percentage abundance of each isotope. So, relative atomic mass of the copper is 63.55. This we can see, this is given. Relative atomic mass of copper 63 is 62.9. Relative atomic mass of copper 65 is 64.9. So these are the values given in the question. If the percentage abundance of copper 65 is X, and because copper is having only two isotopes, so if we have let X is the percentage abundance of one isotope, the percentage abundance of the second isotope will be 100 minus X, because there are only two isotopes. So the percentage abundance of copper 65 is X, then the copper 63 will be 100 minus X. Now same method will be followed which we have followed in the above question. Multiply 62.9 with X and 64.9 with 100 minus X, close it into the bracket, whole divided by 100 here should be equal to the relative atomic mass of the copper, that is 63.5. So now solve it on the calculator, you will get the answer of X. And X is the percentage abundance of copper 65. So now this X will be placed in this factor 100 minus X, you will get the percentage abundance of copper 63. This is here. Okay. Here is another question. Carbon's atomic number is 6. Most carbon atoms have a mass number of 12. A few has a mass number of 14. Draw the two isotopes of the carbon. So we are given some things and required to draw the structure of the isotopes. So the isotope which is having mass number 12, first we have to draw the nucleons. There are 6 protons and 6 neutrons. So 6 protons and 6 neutrons will be drawn into the nucleus. And in the second isotope, we are having mass number 14, but atomic number is 6. So 6 protons and 8 neutrons will have to be drawn because mass number is 14. There will be 2 shells in each isotope and electrons will be 6. So first shell will have 2 electrons and second shell will have 4 electrons. Same wise in second isotope, that is carbon 14. Again, because proton number is 6 in both isotopes. So 2 electrons will be placed in first shell and 4 electrons in the second shell. So these are the isotopes. So this was the topic, students. Read it again and make your notes. Thank you so much.